Hello and welcome to Engineers Mindset Academy. So in today's class, we are going to be talking about numerical analysis using the Gauss-Seidel approach to evaluate the given system of equation. Alright, so let's consider the question on the board. It says, use the Gauss-Seidel method with over-relaxation 1.2 to solve the following system of equation until the percentage relative error falls below 5%. So we're given this system of equation. Now take note, in this equation we've been given here as 0x3, we've also been given here as 0x1. So this simply means that this was made as easy as possible for you. In most cases, you will not have a value for what? There will be no value here, which means you simply have x1 and x2. But if the equation or system of equation actually involves x1, x2, and x3, it means that if in the first equation you don't have any variable or any value for variable x3, automatically it becomes 0. Just like in this third equation as well, you have 0x1. Now this equation could actually start with minus 0.4x2 plus 0.8x3. So this simply means that there is no x1, and hence the coefficient of x1 there is simply what? 0. So but this has been made as easy as possible by introducing 0x3. So just know that if the system of equation is up to 3 variables like x3, and like in the first equation there is no x3, automatically each variable or each coefficient is simply what? 0. Same thing here is simply 0 too for x1. Another thing you should have in mind as well is the system of equation can be scattered. You could have 0.4x2 coming first. Maybe you could have x1 here and then x3 in the middle. All you need to do is to simply what? Arrange the system of equations such that you have both x1, x1, x1 on this whole side of the equation, and then you have x2, x2, x2 on the middle side, and then x3 on the this other side. So you should be able to also note or watch out for the arrangement of the given variable. So it should be in from the lower terms up to the highest variable. So it should be x1, x1, x3 in all. So should, in case they are mixed or scattered, be very careful to what? Rearrange the equation to be in terms of x1, x2, x3, and so on. Alright, so without further ado, let's get straight to the question. Now, using the Gauss-Seidel method, our first task will be to rearrange these equations. We are now going to write this equation in terms of x1, x2, and x3. So we'll solve for x1 in equation 1. That's the first task we are going to do. Solve for the value of x1 in equation 1 by simply sending every variable here to this other side of the equation. So we need to make x1 subject of the formula. That's what the Gauss-Seidel approach is all about. We make x1 in equation 1 subject, make x2 in equation 2 subject, and make x3 in equation 3 subject. Okay, so if we do that, from here, from equation 1, I will simply have 0.8x1 is now equal to, so I want to make x1 subject of the formula. I will simply send every other terms here to this other side of the equation. Now, not forgetting, we have 41 on this side of the equation, so you simply put it down, 41. Then again, minus 0.42x2 crosses over to this equal to sign. Negative sign cross an equal to sign automatically becomes positive. So therefore, we simply have plus 0.42. Okay, 4x2, sorry, plus 0.4x2. Similarly, if I send, of course, 0x3 over here, 0 is 0, there is no need for it, so you can simply what? Keep it as 0. It's off. Okay, so this simply means that our x1 is now equal to 41 plus 0.4x2 all over. In order to make x1 subject, you divide through by what? 0.8, which is the coefficient of x1, so that x1 will be left alone. So we simply have this to be all over 0.8. Now, had the equation has no over-relaxation, then we can simply solve with our x1 like this. But due to over-relaxation, we have to now what? Convert this equation by what? Multiplying the whole of this equation simply by what? The value of the over-relaxation. Therefore, we are simply going to have x1 prime. Now, this prime simply means the number of iteration. X1 simply means now x1 is of course this variable, then the prime on top here now simply means the number of iterations. So if it's the first iteration, we'll simply use x1 to the power of 1. If the second iteration, we'll use x1 to the power of 2. That's if we're iterating this same variable second time, it becomes x1 to the power of 2. If it's the third iteration, we have x1 to the power of 3. So prime here simply means the iteration. So this x1 prime is simply the one we are going to iterate, simply because there's an overrelaxation of 1.2. Now, what does this overrelaxation, how does it affect this equation now? You simply have this to be equal to, use the value of the overrelaxation, which is 1.2, to multiply the whole of this equation. I will simply have 1.2 multiplied by 41 plus 0.4 x2 all over 0.8. Then again, it doesn't end there. You simply add plus, open another bracket, 1 minus the value of the overrelaxation, 1.2. It becomes 1.2 times x1 itself. This becomes the variable or the equation you're going to iterate due to the overrelaxation. Not forgetting, use the overrelaxation value to multiply the system of this equation, which you've converted for x1. Then you now have 1 minus that value, 1.2 multiplied by x1. So which means the variable we are going to iterate now for x1 is now x1 prime is now equal to, so you can write this as simply either you put at 0.8 here, it's still the same thing. You have 1.2 all over 0.8 is still the same thing as this. Okay, multiplied through by, this becomes now 41 plus 0.4 x2. So you might also wish to use 1.2 to expand everything on top here. You're not wrong. Or you can pull this out. It's still the same thing as the whole of this. Alright, so here now, 1 minus 1.2 obviously will give us minus 0.2 x1. Okay, so call this equation 1. So this is now the first equation which we are going to iterate for the variable x1. So you repeat the same procedures for all the other equations. Remember, using the Gauss-Seidel method, equation 1 has to give you the variable of x1. So we'll use equation 2 now to find the variable x2 from equation 2. So we need to make x2 subject of the formula from equation 2. Okay, so we now consider equation 2. Consider equation 2. Consider equation 2. We need to now make x2 subject. So remember, we have 0.8 x2 here. You keep it 0.8 x2. So we simply send every other terms here over to this side of the equation. But remember, in this equation, we have 25 on this side. You put it out, 25. Then again, this is minus 0.4 x1. Negative sign, cross and equal to sign becomes positive. So you simply have plus 0.4 x1. And you also have here minus 0.4 x3. Negative sign, cross and equal to sign also gives us positive. So we have plus 0.4 x3. But what we need to do is to make x2 subject of the formula, which means we have to divide all through by what? 0.8, which is attached to x2, so that x2 will be left alone. If we do that, we are going to have that x2 is now equal to 25 plus 0.4 x1 plus 0.4 x3 all over the coefficient of x2, which is 0.8, all over 0.8. Okay, so you simply have this. Now, but not forgetting, there is an overrelaxation value of 1.2, just like we did in the first case. Had there not been any overrelaxation, it means we will solve with this equation. I will do a different video explaining when there is no overrelaxation, how we can also solve using the Gauss-Seidel approach. But now, because we have an overrelaxation, same thing you did here, use the value of the overrelaxation to multiply the whole of this equation. Then you add plus 1 minus that value of overrelaxation, which is 1.2, multiplied by what? x2 in this case, because we are not talking about x2. Okay, so the system of equation which we get when we attach that overrelaxation becomes what we are going to iterate. So therefore, we simply call that x2 prime equal to, the prime tells you now that this is the particular equation which we are actually going to what? Iterate, or use the Gauss-Seidel approach to what? Solve. This is simply iteration. Okay, that's the equation we are going to iterate, just like this is the equation we are going to iterate. Okay, this for x1. This will be the equation we're going to iterate for x2. All right, so we'll repeat the procedure. Remember, the value of the overrelaxation is 1.2. You simply use 1.2 to multiply the whole of that equation, which is 25 plus 0.4 x1 plus 0.4 x3 all over 0.8. It doesn't end there. Now add plus 1 minus the overrelation value 1.2 now multiplies by x2. It's as simple as this. Okay, it's as simple as this. So if you evaluate like I did in the previous case, I will simply have x2 prime, which is the one we are going to iterate, is now equal to, you might wish to use 1.2 to expand everything here. It's not a problem, but I choose to bring out 0.8 here. I will simply have 1.2 all over 0.8 multiply all through by 25 plus 0.4 x1 plus 0.4 x3. Okay, now take note, 1 minus 1.2 will simply give us minus okay, please, this is actually 1 minus 1.2 x2, please, so you don't mistake it. This is also 1 minus, take note of this, please. Okay, this is actually 1 minus 1.2 x1, please, x1, so that you can be able to subtract. It's not the x1 is not attached to 1.2. Please take note of that. All right, so this will simply give us 1 minus 1.2, of course, is minus 0.2 minus 0.2 x2. So call this equation 2. This becomes the variable which we are going to iterate for the second equation, x2. So we'll repeat this for what? X3. Now, equation 3 is to make what? X3 subject to the formula. So note the difference. In equation 1, we made x1. In equation 2, we made x2. So in equation 3 now, we make x3. So consider equation 3. Consider equation 3. Consider equation 3. From equation 3, we have 0.8 x3. Okay, so we can put it out. Okay, this is 0.8 x, this is 0x1. Of course, we can discard this, and then we have minus 0.4 x2. Remember, there's 105 already here, so you can simply send minus 0.4 x2 over here. Negative sign cross and equal to sign becomes what? Positive. So we'll start with 0.8 x3. You have here 0.8 x3 to be equal to, remember we have 105 there already, then we have minus 0.4 x2 there. Okay, minus 0.4 x2 minus cross and equal to sign becomes positive, so this becomes plus 0.4 x2. All right, so but we need x3 to be the subject, therefore x3 is now equal to, you divide all through by the coefficient of x3, which is 0.8. You have 105 plus 0.4 x2 all over 0.8. You simply have this. Okay, so due to the overrelaxation, like I said, due to overrelaxation, therefore this becomes okay, x3 prime, which is now what we are going to iterate, is now equal to the value of the overrelaxation multiplied by everything here. Overrelaxation value is 1.2. You simply have 1.2 multiplied by 105 plus 0.4 x2 all over 0.8 here. Okay, now remember, plus 1 minus overrelaxation value, which is 1.2, now times x3. You simply have this. All right, so the third equation, which we are going to use to iterate x3 prime, becomes, like always, I will simply use 1.2 all over 0.8, multiply everything here. We'll have 105 plus 0.4 x2, and of course 1 minus 1.2 gives us minus 0.2 x3. So you call this equation 3. All right, so these three equations, equation 1, equation 2, and equation 3, are the equation which we need to carry out our iteration. So we can now start the iteration. Okay, so we can now start our iteration, but please keep in mind the question says you iterate till the percentage error falls below 5%. You have to keep that in mind as well. Okay, but before you do anything about the percentage error, I will simply advise you iterate up to 3 times first before you can start checking for percentage error, because of course, it will not occur in the first 2 iteration or 3 iteration, although depend on the percentage, but I think 5% is very small, so we'll have to iterate at least up to 3 times, then we can now check the percentage error and see if it has fallen. Now, in this case, they are not asking us to iterate till it converges. They are actually asking us to iterate till the percentage error falls below 0.5, sorry, falls below 5%. So which means we don't have to iterate till it converges. It is when that condition has been met. If we evaluate the percentage error and it is below 5%, then we can stop our iteration. So for the first iteration, that's simply iterating equation 1. Okay, so you simply set for the first iteration, set x1 to be equal to 0, x2 to be equal to 0, and x3 to also be equal to 0. For the first iteration, that's iterating equation 1. Remember, I said prime here simply means the number of iterations. So this becomes what? X1 to the power of 1, okay? Even though it looks like prime as well. X1 to the power of 1, which means iterating x1, the first iteration for x1. Now, this is equal to 1.2 all over 0.8 multiplied by, of course, we've set x2 to be 0 for the first iteration. X2 is equal to 0. Set x1 as well to be 0. So which means this x2 here becomes 0. This x1 becomes 0. You simply have 41 plus, okay, 0.4. In place of x2, we said let x2 be 0. Okay, minus 0.2, we said also let x1 be 0 times 0. So therefore, x1 prime or x11 is equal to, we have 1.2 all over 0.8. Take note, you can as well evaluate 1.2 divided by 0.8, you're not wrong. Take note, you can as well evaluate 1.2 divided 0.8, you're not wrong, and put the value, you're not wrong as well. Okay, into this is now 0.4 times 0 is 0. I have here 41 plus 0, which gives me 41. Of course, 0.2 times 0 is also 0. So which means that the first iteration for x1 prime is now equal to, so I will simply evaluate this now. 1.2 divided 0.8 multiplies 41. That simply gives us 61.5. So keep this value for the first iteration of x1. All right, so the first iteration x1 gave us 61.5. Okay, we iterate the second variable, which is the second equation now, x2. Okay, we simply iterate x2, which is this now. So the first iteration for x2, we also have x2 1, which means first iteration for x2, and that's equal to, we'll put in their values, we'll have there 1.2 all over 0.8. Don't forget, in this case now, we're going to rewrite x2, please. We'll rewrite this equation now a little bit. Now, the value of x1 now becomes, okay, let me put down the equation. We have here 25 plus 0.4 x1. This x1 becomes the previous value of what? Iteration for x1. We've gotten it. Okay, this becomes previous value of iteration for x1. We have now to be 25 plus, this is now 25 plus 0.4. This becomes x1 prime. The reason why we set x1 here as 0 and x2 as 0 is simply because the previous iterations, there was no initial iterations. Since there was no initial iteration, we simply conclude or assume or simply take that previous iterations are what? 0. So it becomes x1 to be 0, x2 to be 0, and x3 to be 0. But in this case now, we've done an iteration value for what? X1. So we consider all the previous iterations. So this becomes x1 prime, which means previous iteration, okay, for x1. All right. So plus 0.4 x3 plus 0.4 x3. You have here plus 0.4 x3. Now, we've not done any iteration for x3, so we'll still consider the initial iteration of x3, which we consider to be what? 0. So these are all the initial values of iteration. So therefore, x3 will also be considered as 0. All right. Minus 0.2 x2. Same thing, previous iteration for x2 is what? 0. x2 equals 0. But x1, we've already done an iteration for x1, which gave us what? 61.5. Therefore, we're now putting these values into the equation. Therefore, x2 first iteration for x2 becomes 1.2 all over 0.8 into, I have here 25 plus 0.4. The previous value of iteration for x1 gave us 61.5. So you have 61.5 plus 0.4. There was no iteration for x3. Previous iteration for x3 would say the 0. So 0.4 times 0 minus 0.2 times x2 as well is 0. Previous iteration, x2 equals 0. Okay, so we have here x2 prime or x21 is equal to, this becomes 1.2 all over 0.8 multiplying by 25 plus. So we simply evaluate 0.4 times 61.5. We have 24.6. Take note, 0.4 times 0 is off 0. 0.2 times 0 is also off 0. So we end it here. This now becomes 2.1. Sorry. This becomes 1.2 all over 0.8 into 25 plus 24.6 gives us 49.6. And this simply implies that the first iteration for the second variable x2 is now equal to, we simply evaluate 1.2 divided by 0.8 multiplies 49.6. That gives us 74.4. So we'll keep this value now. This becomes the previous iteration now for x2. So this becomes the iterated value of x2. All right, so we are going to now effect this variable into what? Equation 3 to solve for the first iteration of equation 3. Okay. All right, so now we consider equation 3 to iterate, and the equation we are iterating is simply, of course, x3 prime. Now this becomes x3 first, or x3 1, which is the first iteration of x3. All right, so we put down the equation. We have 1.2 all over 0.8 multiplying all through by, here we have 105. This is 105 plus, take note now, this is 0.4 x2, but this is now what? X2, previous iteration of x2, which we obtain as this. So that equation becomes 0.4 x2 prime, which is now the previous iteration of x2, all right, minus 0.2 x3, which is also unknown. Previous iteration of x3 remains 0. Okay, so x3 prime is now equal to, this is 1.2 all over 0.8 multiplied by, this gives us 105 plus, we have 0.4. The previous iteration of x2 actually gave us 74.4. We simply attach that 74.4, okay, minus 0.2. Previous iteration of x3, we set the value as 0, so multiplied by 0, we have this. Okay, so x3 prime is now equal to 1.2 all over 0.8 into this 105 plus, so we evaluate 0.4 times 74.4. That gives us 29.76. That gives us 29.76. Okay, of course, 0.2 times 0 is off, that's 0. All right, so if we evaluate this, we simply have 1.2 all over 0.8 multiplied, so 29.76 plus 105. That gives us 134.6. 0.76. Okay, so we now evaluate 1.2 divided 0.8 multiplies 134.76. This will simply give us that the first iteration for the variable x, for variable x3 is equal to, that gives us 202.14. Okay, so this becomes the first iteration value for variable x3. So we've done the first iteration for all the equations. Next we'll try what? Second iteration. Okay, all right, so we'll try now the second iteration. Okay, so in the second iteration now, not forgetting, we've gotten the value of x1 of 1 to be equal to 61.5. Okay, this is how values we are going to use now. We obtain value for x2 of 1 to be equal to 74.4, and of course we've gotten the value of x3 of 1 to be equal to 202.14. So these are the values we are now going to use to what? Iterate or carry out the second iteration. All right, so we recall equation 1. Please don't forget, I think I've taken it off, but we can recall equation 1. Equation 1, we had that x1 is equal to, okay, we can make it up from here. We have 1.2 all over 0.8 into 41 plus 0.4 times x2, okay, minus, okay, 0.2x1. So this was our equation 1. Please don't forget, these equations are very important because is this equation we are going to be using to iterate. The equations are very important, so don't forget. So this was our x1 prime, which is the equation we are supposed to use to iterate. Okay, so we are now going to modify this equation now for what? We are going to modify this equation for the second iteration. It becomes x1 of 2, which means second iteration. All right, guys, so I think I should shortcut this equation somewhere where I cannot tamper them because I will be needing the equations. Okay, all right, so I'm going to take here off. All right, so I'm going to take here off and place these equations. Equation 1, x11 equals 1.2 all over 0.8 into 41 plus 0.4 x2 minus 0.2 x1. This was equation 1. This is equation 2. Let's also pull up equation 3 up. X3 prime, and that's equal to 1.2 over 0.8 into 105, okay, plus 0.4 x2, okay, minus 0.2 x3. This is equation 3. All right, so I will keep them there. All right, guys, so I'm keeping these three basic equations because they are the equations we are going to be using to carry out all our iterations. So you will need them very, very necessary. That's why I'm keeping them aside here. All right, so I'm not going to erase them. Rather, I will be using their values to carry out our iteration. Okay, so we now need to do the second iteration. To do that, this simply becomes x1 of 2. 2 now means second iteration, and this is equal to 1.2 all over 0.8 into, this becomes 41 plus 0.4. Now this is now x2 of 1, recalling the previous iteration. X2 of 1, which talks about the previous iteration, okay, minus 0.2. This is no longer x1. It's now going to be what? X1 of 1, which is the previous iteration for x1. So we'll use the previous values of iteration to now what? Do the second iteration. That's how it works. Okay, if we do this now, we are going to have x1 of 2 which means second iteration for x1 becomes 1.2 all over 0.8 multiplied by, we have here 41 plus 0.4, x2 of 1 give us 74.4. So it simply becomes 0.4 times 74.4, okay, minus 0.2 times x1 of 1. x1 of 1 is what? 61.5 times 61.5. All right. This simply means that x1 of 2, sorry, is now equal to 1.2 all over 0.8 into 41 plus 0.4 multiplied 74.4 give us 24.6 minus, I have here 0.2 multiplied 61.5. I have here 12.3. So this is equal to 1.2 all over 0.8 into 41 plus 24.6, that's 65.6, okay, minus 12.3, minus 12.3. x1 2 is now equal to, so let's evaluate now, 1.2 over 0.8 multiplied 65.6. So the whole of this value give us 98.4. We have here 98.4 minus, not forgetting, minus 12.3. Okay, so 98.4 minus 12.3. This simply implies that the second iteration for the first variable x1 is now equal to 98.4 minus 12.3. That gives us 86.1. So this becomes the second variable of iteration for x1, second iteration value for x1. Okay, so next up, we simply carry out the iteration for the second variable. So it becomes x2 of 2. Iteration for the second variable becomes x2 of 2, and that is now equal to, remember the formula, x2 of 1, okay, which is the whole of this. Now we're looking for x2 of 2, so we'll now record the previous iterations, not forgetting. This becomes now 1.2, this is the second equation, all over 0.8 into, we have here 25 plus 0.4. Now, take note, it's no longer x1 of 1. The previous iteration for x1 now is simply x1 of 2. So this remains x1 of 2. So you have to take note of that. We are dealing with all the previous iterations as we move down the iteration. So this becomes x1 of 2 because x1 of 2 is the last, the previous iteration we've done for x1. So this becomes x1 of 2 plus 0.4. Take note as well, we've not done x3 of 2, so but we'll have x3 of 1, which is the previous iteration for x3. You put it down, x3 of 1. So all we need to do is we'll reevaluate the expression, putting in the variables for what? The previous iterations. That is all we do, okay? And then we'll continue to iterate. All right, so minus 0.2. We've also not done x2 of 2, which is what we are doing now. The previous iteration for x2 is x2 of 1. So we'll simply attach x2 of 1, which indicates the previous iteration for what? X2. So this is now the equation we are going to use to solve for that iteration. Okay. All right. So second iteration for x2. x2 of 2 is now equal to, we have 1.2 all over 0.8 multiplied by, we have here 25 plus 0.4, okay, x1 of 2, x1 of 2, and x1 of 2 gave us 86.1, so multiplies by 86.1, okay, plus 0.4, x3 of 1, and x3 of 1 gave us 202.14. So 0.4 times 202.14 0.14, okay, minus 0.2 x2 of 1. X2 of 1 gave us 74.4. So multiply 74.4. Okay, so we have this. All right, so we evaluate. X2 of 2 is now equal to, this is 1.2 all over 0.8. Okay, multiplying through by, I have here 25 plus 0.4 multiplies 86.1. We have 34.44 plus 0.4 multiplies 202.14. That gives us 80.856. Okay, minus 0.2 multiplies 74.4. That gives us 14.88. Okay, x2 of 2 is now equal to 1.2 all over 0.8 multiply. So we add all this together now, 25 plus 34.44 plus 80.856. 25 plus 34.44 plus 80.856. That gives us 140.296 minus 14.88. So we evaluate this now. 140.296 multiplies 1.2 divided by 0.8. Okay, we have x2 of 2 to now be equal to multiplied by 1.2 divide 0.8. So this gives us 210.444. All right, so put down minus 14.88. This actually implies that the second iteration for second variable x is now equal to 210.444 minus 14.88. We have 195.564. So this becomes the second iteration for the second variable x2. Okay, having known this, we carry out the second iteration for the third variable x3. That's simply read x3 to the power of 2, which means second iteration. Power 2 here simply means the number of iteration. So second iteration of what? Variable x3. Okay, so remember again to effect the changes in, this is now x3 x prime 3. So this is the equation we're using to iterate now. But take note, this is 0.4 x2. This becomes now x2 of the previous iteration we've done for x2, and the previous iteration we've done for x2 now becomes what? X2 2. So you effect that into that equation. Okay, for the previous variable of iteration we've done for x2. So this becomes 0.4 x22 minus 0.2. The previous iteration value for x3 is simply x3 1. All right, so we pick out that equation now. x3 2 becomes 1.2 all over 0.8 multiplied by 105, okay, plus 0.4. This now becomes x2 2, which is the previous iteration we've done for x2, is right here, okay, minus 0.2 x3, but this is now x3 1 because we've not done the second iteration for x3. That's what we're doing now. So the previous iteration for x3 is x3 1. So plug in the values and then evaluate. All right, so this now means that x3 2 is now equal to, this becomes 1.2 all over 0.8 into, I have 105 plus 0.4 x22 gave us 195.564. 195.564. Okay, you have this minus 0.2 x3 of 1 gave us 202.14. We have 202.14. Okay, therefore the second iteration for variable x3 is now equal to, this is 1.2 all over 0.8 into, I have 105 plus. So we evaluate 0.4 multiplies 195.564. So that gives us 78.2256. All right, so ensure to always take your decimal places maximum to what? 4. It should be up to 4 maximum decimal places unless the question says otherwise. Okay, so minus, we evaluate now 0.2 multiplies 202.14. That gives us 40.428. Okay, so all we need to do now is, of course, evaluate the terms in the bracket first. So we can do that over here. All right, guys. So before I proceed talking about finding the iteration value for x3, second iteration for x3, let's first of all understand what the percentage error is. Because I'm about to wipe this side of the board, but it also plays an important role. Now, to test for your percentage error is simply percentage error for the first variable is simply equal to, it becomes x1 of 2, which is what your current iteration for x1 minus your previous iteration for x2, which is x1 of 1, all over x1 of 2, current iteration for x1, multiplied by 100%. Now, if you evaluate this and you obtain the value as below 5%, it means you can stop your iteration. That's the condition of the question. Okay, if it's not here, you can now test for the second percentage error. Okay, that's error 2, which lies on the second variable x. So that becomes the current iteration for x2, which is x2 of 2, minus the previous iteration for x2, which is x2 of 1, all over x2 of 2, always the present, okay, multiplied by 100%. If you also test this and it is below, if you also test this and it is below, if it is below 5%, it means you can stop your iteration. And finally, if it is not here, you can also try the third percentage error, which lies on the third variable x3, which also remains the current variable of iteration for x3, which is x3 of 2 minus x3 of 1, sorry, minus x3 of 1 here, all over x3 of 2 multiplied by 100%. Okay, where x2 of 2 has a value, which is this 195.564, minus x2 of 1 also has a value, okay, which we've solved. Okay, this is x2 of 1, 74.4, all over x2 of 2, 196.564. So if you do this and multiply by 100, do for the three of them, anyone that falls below 5%, you can stop your iteration. But I've solved this and it does not lie in the first and second iteration. That's why I said before you check for your percentage errors, always iterate at least up to 3 times before you check for your percentage error. If it doesn't fall there, then iterate up to the fourth iteration, okay, before you can stop your iteration. So we're going to now do the third after this variable now. Okay, after this variable, we are going to do the third iteration. Then we can now check our percentage error. So I just wanted to show this simply because I'm wiping these iteration values off. I think we don't need it for now. We can only make use of the second and the third iteration values. All right, guys. Welcome back, guys. So let's proceed from where we stopped. Okay, so x3 of 2, which is second iteration for third variable, now becomes 1.2 all over 0.8 multiplied by, we have here 105. Okay, sorry. So let's simply obtain 105 plus 78.2256. That gives us 183.2256. Okay, minus 40.428. All right, so we evaluate this now. 183.2256 multiplies 1.2 divides 0.8. So this implies that x3 of 2 is now equal to, we have 274.8384 minus 44.428. So this simply implies that the second iteration for the third variable is now equal to 274.8384 minus 44.48428. That gives us 230.4104. So this becomes the second iteration for the third variable x3. All right, so we're done with the second iteration. We move next to the what? For the third iteration. Okay, third iteration. Third iteration. Now, in the third iteration, you have to set the values of what? The x in that equation now. This becomes, the previous values now becomes x1 of 2, and x1 of 2, we obtain the value as, okay, we obtain the value of x1 of 2 as 86.1 over here. So x1 of 2, we obtain 86.1. Next is x2 of 2, and we obtain x2 of 2 as 195.564. We put it down, 195.564. And finally x3 of 2, we obtain x3 of 2 to be this 230.4104. So these are now the new values of iteration, or previous values of iteration we are going to use for the current iteration. So we start with x1. This becomes x1 of 3, which simply means the third iteration for x1. We put down all the values of x1. This is x1, 1.2 all over 0.8 into 41 plus. Take note now, this becomes 0.4 x2, but the previous iteration we just did now becomes x2 of 2. So that's what we're going to effect there. And this is also 0.2, x1 becomes x1 of 2, which is the previous iteration. All right, so we have 1.2 all over 0.8 into 41 plus 0.4. In place of x2, it becomes x2 of 2, which is the previous iteration, okay, minus 0.2. In place of x1, it becomes x1 of 2. It's as simple as this. All right, so let's substitute our values now and see. So we have x1 of 3 is now equal to, it becomes 1.2 all over 0.8, okay, into, we have 41 plus this is 0.4 into x2 of 2 gave us 195.564. So we have 195.564. All right, so like I said, be careful not to actually what? Approximate the decimal places. The maximum you should use is at least 4 up to 4 decimal places. Okay, that's the maximum you should use. All right, okay. All right, so you can close. Also be careful, this is x2 of 2, not actually x2 squared. So you're not squaring this variable. You're not. This 2 here, or the power there, simply tells us the number of iteration. We're dealing with x2 of 2, second iteration for x2. Be careful not to square as well. Minus, this is now 0.2. x1 of 2 simply means the second iteration for the first variable, and x1 of 2 gave us 86.1. So multiplies 86.1. All right, okay, so x1 of 3, third iteration for variable 1, becomes 1 all over 2 all over 0.8 into 41 plus, okay, so we can now evaluate 0.4 multiplies 195.564. So we have 78.2256, okay, minus, we also evaluate 0.2 multiplies 86.1. We have 17.22. Okay, we have 17.22. All right, so x1 of 3 is now 1.2 all over 0.8 into, so let's evaluate 41 plus 78.2256. 41 plus 78.2256. So that gives us 119.2256. All right, so minus 17.22. 22. So all we need to do now is simply 119.2256 multiplies 1.2, okay, divides by 0.8. All right, so multiplies 1.2 divides 0.8. Okay, so that will give us x3, x1 of 3 is now equal to, we have 178.8384, all right, minus 17.22, minus 17.22. So this implies that the third iteration for the first variable x is now equal to 178.8384 minus 17.22. We have 161.6184. So this becomes the third iteration for the first variable x. Next up, let's try this third iteration for the second variable. So x2 of 3, third iteration for x2. This is the base equation, not forgetting. So this x1 now becomes x1 of the previous iteration which we've done. That's simply x1 of 3. So the equation becomes, okay, we'll modify the equation now. It becomes 1 all over 2 divided by 0.8 into 25 plus 0.4. X1 becomes the previous iteration, which is x1 of 3. We have here x1 of 3, okay, plus 0.4. X3 also becomes the previous iteration which we obtained for x3, and the previous iteration we got for x3 remains x3 of 2. That's the previous iteration, so we'll simply attach x3 of 2, okay, minus 0.2. X2 here now becomes the previous iteration for x2, and previous iteration we've gotten for x2 remains x2 of 2. All right, so simply attach x2 of 2, which is the previous iteration. All right, so x2 of 3 is now equal to 1.2 all over 0.8 into, okay, we'll put in the values now. This is 25 plus 0.4. Remember, x1 of 3 and x1 of 3 give us 161.6184. You put it down, 161.6184 plus 0.4 previous iteration x3 of 2. X3 of 2 gave us 230.4104. 230.4104, okay, minus 0.2 x2 of 2, and x2 of 2 gave us 195.564. So we have minus 0.2. I'll take it down here a bit, please. 0.2, okay, multiplied by 195.564. 195.564. I hope you can see this clearly. I have to take it down because there is no space over there. Okay. All right. So let's evaluate these values and see. Can you enter here? Let's try and see. Okay. So x2 of 3 is now equal to, this is 1.2 all over 0.8 into, I have 25 plus, so I'll obtain 0.4 multiplies 161.6184. All right, so this gives us 64 point, I have there 647. Okay, so I have 64736, but then again I say just approximate to 4 decimal place, so it becomes 6474. Okay, always approximate to 4 decimal place unless otherwise stated. Okay, all right, plus, then again I will evaluate 0.4 multiplies 230.4104. 4104. I have 92 points. Okay, take note now. I have 92.16416, that's 5 decimal place, always approximate to 4 decimal place. It becomes 92.1642. Okay. All right, so minus, now we evaluate 0.2 multiplies 195.5565. That gives us 39.113. Okay. All right, so next up, we add this all up together. 92.1642 plus plus 64.6474 plus 25. Let's add them all up together. I think I'll do it over here. It's my duster. All right, so let's add them all up. 25 plus 64.6474 plus 92.1642. That's simply 181.8116. So we have x2 of 3 equal to 1.2 divide 0.8 multiplied by 181.8116. Okay, minus, we have there minus 39.113, minus 39.113. Okay, all right, so x2 3 is now equal to, so we evaluate now, 181.8116 multiplies 1.2 divides 0.8. That gives us 292.7174. Okay, minus 39.113. So this simply implies that the third iteration for variable x3 is now equal to 292.7174 minus 39.113. That gives us 263.6044. All right, so this becomes the variable or the value of the third iteration for the second variable. Finally, let's try the third iteration for the third variable. So x3 of 3, we'll also remember to modify the equation. All right, so from equation 3, we have 1.2 divide 0.8 into 105 plus we have 0.4. Now, it's supposed to be 0.4 x2. Okay, over here it's supposed to be 0.4 x2, but the previous iteration for x2 is what? X2 of 3. This is the previous iteration for x2, x2 3. So it becomes 0.4 x2 3, okay, minus 0.2 x3. But now the previous iteration for x3 remains x3 2. Okay, previous iteration for x3 is x3 2, which is over here. Okay, all right, so I think that is it. So let's plug in the values now. Let's plug in the values. X33 is now equal to 1.2 divide 0.8, okay, into 105 plus 0.4. X23 is rightly here, 263.604, 263.6044, okay, minus 0.2 x3 of 2, and x3 2 actually gave us 230.4104, 230.4104, 4104. All right, so x33 is now equal to, we have 1.2 all over 0.8 into This is 105 plus, so let's evaluate 0.4 multiplies 263.6044. This gives us 105.4418. Okay, minus, let's evaluate now, 0.2 multiplies 230.4104. That gives us 46.0821. All right, so x33 is now equal to 1.2 all over 0.8. So let's evaluate here now. 105 plus 105.4418. 105 plus 105.4418. That gives us 210.4418 minus 46.0821. Okay, so I think I can wipe here now. Okay, all right, so x3 of 3 is now equal to, we simply evaluate 210.4418 multiplies 1.2 divides 0.8. That gives us 315.6627 minus 46.0821. 46.0821. So this simply implies now that x3 of 3 is equal to 315.6627 minus 46.0821. That gives us 269.5806. So this becomes the third iterated value for the third variable x3. So we have this now. After obtaining up to the third iteration, I said you can now test for percentage error. You can now test for the percentage error and see if any of them has fallen below 5%. Okay, so let's try it and see. So I will leave these values because these are our previous iterations. So I'll keep them and let's find the percentage error. Okay. All right. So let's find percentage error now. All right. So percentage error, let's start with the first variable. Remember, it's always different between the present iterated value and the previous. So we have x1 of 2, okay, which is second iterated value. Okay, sorry, it becomes x1 of 3, all right, x1 of 3, which is the third iterated value for x1, minus x1 of 2, which is previous, all over x1 of 3 multiplied by 100%. Let's see if this is below 5%. x1 of 3 gave us 161.6184. We have 161.6184 minus x1 of 2, and x1 of 2 gave us 86.1 minus 86.1 all over x1 of 3, 161.6184. Multiply the whole of this by 100%. All right. So percentage, the first percentage error is equal to, okay, 161.6184 minus 86.1 divide 161.6184 multiplied by 100. All right, so the first percentage error actually gave us, computing this, we have 46.7%, and this is greater than, of course, 5%. So we also test with the second variables or the second values and see. Let's test with the second values. I think I can wipe this. All right, so for the second variables, percentage error 2 is now equal to, it becomes the present, which is x 2 of 3 minus the previous, which is x 2 of 2 all over the present x 2 of 3 multiplied by 100%, and this is equal to x2 of 3 x2 of 3 gave us 263.6044. So we have 263.6044 minus x2 of 2. x2 of 2 gave us 195.564. 195.564 all over 263.6044. Multiply the whole of this by 100%. So the second percentage error is now equal to 263.6044 minus 195.564 divides 263.6044 multiplied by 100. This gives us 25%. So we have 25.8%, which is also greater than, of course, 5%. Okay, let's try the last one. Percentage error 3, and that's simply equal to, it becomes x3 of 3 minus x3 of 2 all over x3 of 3 multiplied by 100. Okay, let's try this and see. x33 gave us 269.5806. We have 269.5806 minus x32 gave us 230.4104. 230.4104 all over 269.5806 multiplied by 100 multiplied by 100. So percentage error for the third value is simply equal to, okay, 269.58506 minus 230.4104 divides 269.5806. All right, so this also gives us 14.5%, which is also greater than 5%. Okay, guys, so I think you have to continue doing the iteration. So you try out the fourth iteration. So what will happen is, I don't think I can, okay, completely do this because the video is getting too long. It's almost more than an hour now. So I'm going to pause the video here. You try out the fourth iteration, then compare the fourth iteration and the third iteration for percentage of error till it falls below 5%. Okay, once it falls below that amount, then it means you can stop the iteration. But if you're having any issues, you can message me on WhatsApp. My number is displaying on the screen, and I'm going to guide you through. Okay, but that is just the basic idea behind the Gauss-Seidel method when it involves over relaxation and, of course, percentage error. Of course, take note, over relaxation can also be termed as weight. So you could be given the question and you're told that given weight, okay, is so amount, then you have to also use the same approach for over relaxation. All right, guys, so that's it on Gauss-Seidel approach with over relaxation. I will see you in the next video. In the next video, I will do a different approach altogether using the Gauss-Seidel when there is no over relaxation. So you can see how that particular one also works. In that case, you have to iterate till the values converge. Okay. I will see you in that video. In the meantime, if you're new to this channel, please do well to like, comment, and of course, subscribe to the channel. I will see you in the next video with more question on numerical analysis. Thanks and cheers.